Okay, I want to do something a little bit different for this session. And the first thing that I want to do is I want everyone to go and download, and I'll dump it into Slack too for convenience. I want everyone to please download the insurance data set, because we only talk about fascinating things here. Insurance. I don't even know if this data set's real. It doesn't actually matter. But the point is that it's a data set that is labeled insurance. I don't know, one of my students can chime in if they know it's a real data set. So okay, now I'm also going to copy paste the actual data set in just so you have it, just so for convenience. So feel free to download it. And what I'd like to do is I'd like to make this project in Quorum Studio. So we're not going to use the web interface for this, and as my cuckoo clock goes. And part of the reason for that I want to kind of point out is that in order to make charts accessible, we have to embed the graphics information through the screen reader APIs. What that means is that if I've got a bar chart with 5 bars, screen readers are like, cool, right on, that's 5 bars. But if you're generating a chart and it has, let's just say, a scatter plot with 100,000 points in it, be aware that takes longer for the computer to calculate. So we're going to do this one offline. And the reason we're doing that is because we can kind of tackle nastier data sets, right? And this is a good lesson in computer science broadly. If you have a small little data set of a couple rows, toss it in a CSV and don't care. But if you're running a database on a web server and it gets a lot of hits, well, you kind of need something beefier because you might get a lot of stuff. You know, you might get a lot of requests and things like that. Okay, so now I've then gone through and I've made a project, and I can walk people through making a project again if we want, but I made a blank project. Okay, and then I put the insurance file in there. Oh, I'm sorry, I wasn't going to do this first. I was going to look at the file. So the first thing that I want to do when I'm actually doing data science for real, the first thing I do is not start coding anything. I don't do that at all. The first thing I do is I go and I look at the data. And so everyone, you can either look on the screen or you can grab the data and toss it in Excel or whatever works for you. Everybody take a look at this data for a minute, this insurance.csv data set. And let's think about it as a group for just a moment to try to figure it out. Because here's the thing. We have to remember that in data science, the goal isn't just to code whatever we want to do. Our goal is to learn something. And data sets can do that. Now, let's all presume for the sake of argument that this data set is fake. It doesn't really matter. But let's presume that it is. So let's assume it's fake data. But imagine, for the sake of argument, that it were real and that you were trying to learn something from this data set. Maybe you had appropriate protections in place for people. Maybe you had whatever it is that you needed. But the point is that imagine, for the sake of argument, that this is a real data set. Let's take a look at it. And can someone please tell me what they observe about this data set, just from the data set before we've done any charting at all? Any observations about this data set?
Demographic?
It has some demographics, but only a few of them, right?
Yeah.
So like it has your BMI, children, and smoker, but not much else. So that's interesting. And sex.
Region. Age. I mean, all those are demographic, but I mean, the last one, well, the last one is charges, which I'm assuming is insurance charges, which is really funny that the decimals go as far as they do. I didn't know we had percent. I didn't know we had hundredths of a penny and such, but that's pretty interesting.
I thought that too. And also notice that, oh, sorry, someone tell me about the smoker column. Do you notice anything there?
It's not numerical, it's yes or no.
It's just yes or no. Is that reasonable in data science? Yeah, so I see some head shaking, and my point isn't necessarily to bash this data set. My point is that whenever you're looking at this, it's really easy to just go make a chart. But when we collect data for real, we have to remember that this stuff is messy and we need to have checks and balances in our head for how to interpret what we're observing. And so when we do this lesson today, keep the data set itself in mind as we go through it. And let's try to imagine the limitations of what these charts might be telling us. This is sort of the data science kind of story, if you will, right? You know, how do we go? We go and we collect it. We look at something in the field. We kind of get some numbers or some values, and then we kind of do something with them, right? And we have to not underinterpret or overinterpret. And that's always kind of a pendulum or a balance, if you will. Okay. Now, the next thing that I'm going to do is I'm going to go ahead and load my data set, and I'm going to share my screen for Quorum Studio. Now, by the way, I just want to point out, if you can see it on the very bottom of my screen is some really weird junk that says LWJGL, GLFW platform error. You can ignore it, but here's the thing. If you have an M1 processor for a Mac, you will see these errors in there. They don't seem to cause any harm, but we haven't figured out what they are. So like, just ignore them for now. In any case, the first thing we're going to do is we're going to type data frame. And we're going to use the automatic injector thingy, Bobby, whatever it's called, editor hint, to generate the stuff, generate the use statement. We could memorize that, but we remember that it's not useful to do so because there's thousands of these and no human could possibly do so. So memorize them is generally not useful, not something to teach in the classroom. And then we're going to load our data set. And we're going to load it from a text location. And I placed mine just right in my folder. So I'm just going to say insurance.csv. And I'm going to output it to the screen, but I'm going to show you just one little trick. You'll notice that on the screen there, when I was going to type 2 text instead of for the output, there's actually 3 of them. There's 2 text, there's integer rows, and then there's integer rows Boolean header with or without the header. For the sake of argument, just to show you that it exists, because it's kind of convenient, I'm going to have 2 texts. I'm going to put 5 in there, and then I'm going to write an output ahead of it. And it's only going to print out the first 5 rows. And the reason I'm doing that is because sometimes if you have a giant data set, you really don't need to print out the whole thing. You just want to know that you're getting this stuff there. So there we go. There's the first 5 rows of my data frame. It's just a convenience. There's lots of ways you can print this stuff out. You can look at it in the spreadsheet, whatever. I'm just, the only reason I'm even doing this is I'm verifying that it loaded how I expect. Okay. Now, the next thing is I have age, sex, BMI, children, smoker, region, and charges. Okay. And my goal is I'm going to make a scatter plot, but scatter plots have a purpose. What is a scatter plot for?
To show like clusters.
Okay. What else?
So it shows you individual data points with 2 variables, but it shows all of them. And so you can visually, you can actually sometimes see trends, or you can see that there are no trends, that it's all over the place. I mean, so it's a way to look at data quickly from a visual standpoint to determine if the data is going directionally in some way or not. That's the way I look at scatter plots.
I was going to say to hand miniature weapons to children because we give them push pins.
Clearly, yes. Okay, so then what we're going to do is I'm going to get rid of my little output statement because I no longer need it because I have that. And I'm going to add some selected columns. And if I'm doing data analysis or data science for real, I want to keep what I care about to an to an absolute minimum. In other words, you don't want to just dump in a bunch of variables when you're doing data science, because oftentimes it can get very complicated very quickly, right? And so what I want to do as a starting point is I'm going to add 2 columns, the X and the Y. Which ones should I add? What would you prefer? I'm going to, how about, actually, no, I'm going to wait. I'm going to choose. I'm going to choose BMI and children because I just suspect.
Okay.
Okay. So I'm going to say frame, add selected columns. And I'm going to say BMI children. And on the screen, I think this works. We're going to find out, aren't we? I think you can actually comma separate them as well. You don't have to put them as separate lines, but I think I added that. I think I wrote it, but I'm not positive. Anyway, we're going to find out. And if I didn't, then we're going to find that out too. So in any case, and then what I'm going to do is I'm going to make the scatter plot. So frame, scatter plot. And when I do this, it actually pulls up has a little red underline, meaning that it has an arrow on a screen reader. It should make a little beep sound. It'll be the misspelling sound. The actual command we send down to the screen reader says that there's a misspelling there. There is no compiler error screen reader sound. It just doesn't exist. So you get the misspelling sound. That's the one that it will do, at least on UIA on Windows, so that, oh, and then JAWS or NVDA choose whether they respond to that. So that's not our choice, which is kind of funny. But anyway, never mind that. In any case, though, there's a hint there. And the hint is, hey, would you like to add use for libraries.interface.controls.charts.scatterplots? And we say, yes, please, thank you.
Remind me again how you got that. Remind me again how you got that to pop up when you clicked on value.
Yeah, no problem. So if I get rid of it, it goes back to the same state.
Right.
And if I right click on it.
Okay, got it. Sorry. All right.
Nope, no problem at all. And then I'm going to name mine chart. And I'm going to just call chart, comma, display. Because I'm trying to keep my code simple. And then I'm going to put my code into Slack so people can copy it freely. And there might be an error, there might be problems. That's okay. We're building it up. I'm then going to run it.
It runs. Oh, there it is. Oh.
And when I run this, I get a chart. That looks like this. Okay, so I'm hypothesizing in my data science world that there might be a relationship between BMI and children. It's just a hypothesis. I might be right, I might be not. So answer me this. And if you have a screen reader, I'll give you a minute to examine this through your screen reader. And it is difficult with scatter plots because there's a lot of points. I feel like we still need to do a little bit of work to figure out how it should feel for scatter plots, but never mind that for a moment. What do you think? Is there a relationship between BMI and children or no? Keep in mind, we're imagining that this is fake, but just for the sake of argument, pretend that it's a real.
All right, so children is the number of children that the person has. So we got to keep that in mind, right?
Yep.
So
potentially.
But yeah, I mean, that's what the data said.
It might be the number of children they've eaten per week, but I'm assuming not.
Right. Okay. So obviously the mass majority have 3 or less.
Yep. So visually, if I describe this, in the very top row, it's kind of sparse and it kind of goes through the spectrum between 15 and 55. In row 4, it's more clumped in the middle of BMI, not much on the far left or the far right. In 3, there's a lot more data for any of them going down, like Derek is saying, and they're definitely more clumped in the middle-ish, 30-ish BMI, and then kind of all around there. And I'd say that that's largely true for the others as well. It might be a little bit more to the left for 0 or 1, but it's not clear from the data. From a screen reader perspective, you get this like point at a time, so it's pretty difficult to figure out, but you know, we'll figure out, I don't know exactly what the solution is there, but at least it's something. It's better than just an alternate description. So just by a vote in Slack, is there a relationship or not? You got to take a stand, yes or no? Everybody vote in the Slack channel, please. I see 4 votes. 5, 6, 7. Maybe.
No, Tim, maybe is not an appropriate answer.
So this is the tricky thing about data science. Unfortunately, as human beings, we often like to think of questions as having yes or no answers. In data science, essentially, it's actually the opposite. There really aren't any yes or no answers. It's all probabilities. And so what that means is the only answer is maybe, but it's shades of maybe, right? And so in a sense, Tim Lockwood is right, although not really. Okay. So, okay, so here's the problem though. The problem is when we make a chart like this, when we're doing actual data science, we're not just making a scatter plot. That's not the point. The point is we're trying to use information generated by the computer to make a decision. For example, maybe you're a public policy person and you're trying to help people with children in some regard. I don't know. Okay, so let's take a step back and let's build up this chart again and see if we can't look more at the relationship. For example, why don't we just add a trend line? Or actually, no, before we do that, let's actually, of course, I accidentally built it again. Let's flip it around. Instead of children and then BMI and then children, let's just make it BMI and children and BMI. In other words, let's flip the axis. Maybe that'll help us.
So we just changed the order then in the column, the add column. Oh, yeah.
Yep.
Let's put a space in it this time and see if it works.
It does not, because I had that problem.
Oh, yeah, it doesn't allow spaces. Sorry. I probably should add that, but I didn't. It's not the same. Oh, I wonder if you have to do them separately for that. Okay, let me try that.
I'm finding it difficult to maneuver.
Yeah, I actually think in terms of screen readers, the scatter plot is the most difficult one because there's a lot of points. Yeah, okay, that's my fault. If you don't,
It's running the same chart.
yeah, I got a feeling that what's happening is when you combine them like that, it sorts them or does something like that first. So I separated out the 2 columns and I put that in Slack as add selected columns, children, add selected columns, BMI, and then it shows up how I expect it to.
Oh.
Yeah.
Oh,
So,
instead of
sorry.
separated by a comma. to a-
Yeah, my
okay.
fault. I added the 2 lines.
See,
Okay.
I would have tried to lump them together too.
Yeah, that's the first thing I thought to do. Okay, so now, does this help us flipping the axes?
Not really. Not really.
Not really, right? Okay, let's try other stuff.
Does the order in which you put them is separated out make a difference?
It should, yeah,
Okay.
because one's X, one's Y, and I think it does it in order. I
In
think-
order.
Yeah, I think
Oh.
the top one is X, and then the bottom one is Y.
Okay, that makes sense.
Okay, let's do the next thing. Why don't we add a, oops, I'm not sharing my screen, aren't I? Let's add a trend line. Maybe a trend line will help us. So to add a trend line, we're going to say chart. And then we're going to say show linear regression. True.
You're putting that before the display.
Yes. Because the display tells it to render to the screen. Show linear
Right.
regression says what to do when it renders to the screen.
Right. I was really saying that for the.
No, you're all good, dude. Oh, right. No, that makes sense. Thank you. Okay, so to kind of go over it again, we have a data frame. We're loading the insurance file. We have two selected columns, no factors, children and BMI. We have scatter plot line where we're making it. We show linear regression and then we display it. And when we display it, I'm going to show that and I'll orally describe. Okay, now what we observe here is some really funny stuff. Okay, what we observe, and we'll talk about this a little bit more tomorrow, but I want to highlight it today because it gets a little bit tricky, is I've got a line, it starts about 30, that's BMI, for 0 children. And then by five, it gets up to maybe 31 by 5. Okay, that's the trend line. So BMI went up.
Did.
So what does that mean? And for this, because Derek has a lot of stats training, I want him to not answer for this particular one.
If I popped out 5 kids, yeah, I'd be fatter.
Well, that's an intuitive thing, right? But is that actually what this shows?
No, but
And this is a really tricky lesson in data science, and it's hard to understand. What does this chart actually tell us?
They were fat. That were
Anybody
not
have a clue?
muscular. They were not muscular. That's what I was
Not muscular. I might call in someone at random. Don't hate me. How about Tiffany? Are you willing? Do you have a guess?
No, I like, because I would have thought that at the 0 children, there wouldn't have been any data. If you didn't have any children, so why do you have data? So I don't even know how to.
Oh, this is I should have said, for the sake of argument, this is the number of people with no children and the BMI that they have, like their weight, the weight calculation thing.
Okay, well, that's where I missed it. So this is adults and how their BMI changes after they have kids.
Yeah.
Okay.
I mean, well, sort of.
No.
It doesn't tell us anything about their ages. This chart is only the number of kids that they have related to BMI, and that is all.
Well, what's really interesting is that it includes males and females too. What would be interesting is see if you were able to pull out the males, if there would be a bigger difference.
Would need to column split.
Well, so here's the thing about data science. Before we do that kind of stuff, trust me, I have that planned. But because Derek knows where I'm going here. But what does this one tell us? This is a lesson that I do with my students a lot. We look at a chart, we generate it, we describe it, we think about sometimes about what the stats say with it, and then we have to come to a conclusion. Does this alone tell us anything? Is the relationship between children and BMI meaningful on its own? What do people think? Let's do a vote.
Not significantly.
Well, we'll get to that. That's a complicated question. It goes up, right? Between 30 and 31, ballpark. So isn't that enough? If the answer is I don't know, can people type like I don't know into the thing so that I know like people haven't been engaged on this kind of stuff before? Don't forget, I usually teach PhD students this stuff, and so they've taken a bunch of stats and stuff. Okay, perfect. Okay, so here's what's going on. Oftentimes when we look at data in practice, it's spurious. It goes up, it goes down, it moves around. And the problem is that doesn't mean anything, right? The data goes up, But that doesn't mean that there's actually a relationship there. This is not correlation versus causation, although that's a real thing. This is not that. This is that you observe a trend and you're wrong because that trend is not real. But here's the catch. Not real is not specific enough. So we often use the language of mathematics and statistics to represent what that is. Now, I won't get into that until tomorrow, but on this legend, there's a little thing that says BMI equals 0.06 children plus 30.59, R squared equals 2.0 e to the minus 4. What that means won't be clear yet, but really what that's telling us is that these things are not predictive. They do not correlate well, right? There's no real obvious relationship between them. The fact that it goes up is incidental, right? But here's the catch. In statistics, and this is very important, if you remember one thing about stats, this is the thing to remember. You cannot tell the difference between no relationship and unknown, right? It could be the case, not unknown, and a lack of evidence. It could be the case that there's no relationship here. Or it could be the case that we don't have enough evidence to determine whether there's a relationship here. And you can't tell the difference between those things statistically. It just doesn't work that way, right? It's just the way the equations are structured. You know, they're designed to require a certain amount of evidence at a certain amount of size. It's a thing. So the point is, in this particular chart, we don't really have evidence of a relationship. So then the next thing that we do whenever we get a chart like this is we go back to the drawing board. So we go back to our data set. So I'm going to pull that up again. Now I'm assuming that there's some relationship here. I could be wrong. But I've got age, sex, BMI, children, smoker, region, and charges. And let's just say, for the sake of argument, we're looking for the relationship between two BMI. Two BMI. Which of these other things do you suspect might be related to BMI?
Well, sex.
Possibly sex.
Region will too, because, well, the Southeast is fatter than the rest of the country.
Okay.
But of course, BMI is not necessarily fat, but I mean, it is.
No, I know what you mean. Yeah. By the way, I should say, this is just, it's an insurance data set. I probably should have chosen one that didn't use BMI. I know that's a sensitive thing.
Well, age is exactly what, that's, Leslie's right. Age is a big part of that too. You lose muscle. I mean, BMI is an indicator of how much muscle you have. And so as you age, you lose muscle.
Yep. All right. So normally what we do then is, instead of just, making a guess, what we do is we hypothesize about it. We come up with a hypothesis about what is going on in our data set, and then we go try them out. And before we do any kind of statistical testing at all, and we're not really going to get through much stats in EPIQ this year, we're just kind of like doing data exploration. We go and we generate charts about it. We examine them, right? So let's do that. So let's try age next. So we're going to do, instead of children and BMI, we're going to do age and BMI. We change one thing. It generates the new chart. And I've got a new chart. All right. Now, in this particular case, I'll orally describe this chart because all of these are going to be difficult to understand in a screen reader because there's just a lot of points. These are big charts. You'll notice that the data is a big mess. Age goes from 15 to 65. And the trend line does go up a bit. Okay. In this particular case, the BMI starts a little below 30 at 15. And then by 65, it seems to get up to about 32 and a half or 32, somewhere in that ballpark. The points have a lot of dispersion, meaning that you'll notice that if you can do this with a screen reader too, if you know the spot on the trend line that you're at, you can ask yourself, where are all the points in relationship to the line? Let's take 15. Right to the first sort of column, right around 15, shows that the trend line predicts statistically that at that age, people should have a BMI around 30. But you'll notice that the BMI range goes from right below 55 to right above 15. That's a huge range in BMI. And unfortunately, it doesn't get much cleaner. So as you go through the rest of the chart, it's always this huge swath between, you'll notice that the bottom does go up a bit and the top does go up a bit as well. But it's not a clean relationship. If this was a clean relationship, all these points would be, in a way, closer to the line. And so this is the second thing about understanding your data with things like scatter plots. As the dispersion increases, the data gets less accurate. I mean, sorry, the results or the conclusions you can draw get less accurate unless you have more evidence. And when you think about it, that makes sense. If you want to find a definitive relationship between age and BMI, there isn't quite enough data in this particular case to really draw a firm conclusion. But what if you had 10 million people? Well, all of a sudden, you have a tremendous amount of evidence. And so the fact that there's a lot of dispersion is kind of irrelevant, because it would tell you that as you get older, that your BMI does go up a bit, which is actually a true statement, but not really enough from this particular data set. Okay, before I keep going, any questions on this one? Do you understand so far? Okay. And hopefully you see what I'm doing. I'm not just building a chart for funsies. What I'm doing is I'm exploring funsies. Yes, Derek, funsies.
Yes.
What I'm doing, funsies, is I'm exploring a hypothesis. And so this is where, as a teacher, you have lots of cool things you can do with your kids in the classroom. For example, you can have them collect their own data in their own local context or whatever. You can have them find data sets and come to their own conclusions about stuff. Tell them nothing. The goal is exploratory. So like they get to go in and generate their own scientific theories based on data, and they can start just by generating these charts and exploring them in an accessible way. There's lots of great activities. Oftentimes, just to give you an example, when I'm in the classroom teaching this stuff, I actually often take academic papers and I remove all the axes from the papers, and I remove all the headers and labels, so they have no idea what the data is about. I just show them the chart and I say, what's the p-value? Right now, the p-value doesn't really matter in this context. We'll get to that kind of stuff later. But I'll ask them questions about what the statistics would show. How big is this effect? What do you think that they found? And the idea is to give students a sense of how to look at data and come to conclusions with only a little bit of context. And that has a lot of value because you see charts in the news. You see charts put out by agencies, by corporations, all sorts of groups. Those might be true and they might be a lie. And being able to differentiate between the two is a really important skill. Okay, I'm going to turn that one off. And then I want to ask, Right. Okay. So the next thing that I want to do is when I look at this data set, there's other hypotheses or conclusions that I could draw. And it could be the case that some of these other factors are involved. So typically in data science, what we want to do is we want to go through them all one by one and try to figure out whether we're missing something. So the next step is on our own for maybe the next 5 minutes or so. I want you to change and connect the other stuff to BMI and come to your own conclusions about it. This is the exploratory part. Okay, so I'm only going to give you 5 minutes for this. So 9:42 is when we'll stop. But I want you to put in each of them, examine the chart, and try to come to a conclusion about what you think it means.
Now,
Okay,
with the filtering we did yesterday, can you do something like the smoking column and exchange all the yeses for ones and all the nos for zeros and pull something
absolutely can. That is part of what that sort of stuff is for.
cool?
Yeah, and in fact, I'm going to get to, I have an example queued up that builds on something that Amanda talked about earlier, and it'll give you a sense. So, but I haven't done it yet because I want to do this exploration thing first. So just try each one of them, and this is the kind of things that you can have your kids do. Is try each one of them and ask them, what's your hypothesis? What is related to BMI from this data set? So just a few minutes. If you're not sure what to do at this step, just change all of the names, all of the selected columns. That's all you have to do. And then you can look at each chart individually and make a conclusion about what you think it means. Okay, 2 more minutes. Go, Mike, go, 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 go. You just looked stressed for a second. So
I honestly have no idea what's going on. We have
okay.
2 in-person camps running around the building, and they keep pulling me for all this stuff. So honestly, my statistical knowledge is very low to start with,
Okay.
and then getting like 5 seconds here and 5 seconds there on 2 different lessons, I have no clue. Are we still using the insurance data set?
We are.
Oh, cool.
We've learned that you owe us money. That's what we're
Yeah,
Sorry.
that sounds about right.
Yeah, that's how all insurance works. So. Okay, 30 seconds remain.
Oops.
When you're done, if you have a particular hypothesis you would like to support, I think this one matters, this one doesn't, feel free to toss it in Slack. And importantly, for anyone that does not toss it in Slack, don't bash anybody else's hypothesis, right? Let people make their hypotheses in a free and open sense, because that's kind of the reality of scientific discourse. So you have to be able to speak freely. Nothing matters. I'll let people type it out, and then we will keep going. People in the Southeast region seem to have a higher BMI. That's Louisa's thought. It seems the only one that seems to matter to BMI is charges. The higher the BMI, the more you have to pay. Yep. People with children have a higher BMI. The older you are, the more you are charged. Okay, this is great. So, and this is really what happens in science. People get these data sets and they ask exactly these kind of questions. Okay, wait a minute, but I see this charge data is going up. And what about this? And so you probably realize pretty quickly that you could come up with all sorts of hypotheses. And this is essentially a fake data set that is just, you download it, or I don't know if it's fake, but you get my point. And so like when you get real data sets, especially ones that are large, boy, the number of questions that you could ask gets pretty astronomical. And so you need a way to kind of filter and to chunk it down. Okay, the last example that I want to give is just to make it even crazier. Instead of sometimes when you're doing this kind of data, instead of just having oh, I'm sorry, I meant to show the spreadsheet. Sometimes you have an idea about your data set that you think it might be true, but may not be easy for you to test. For example, let's suppose that you hypothesize that age and children in some combination is related. So for example, let's just say for the sake of argument that you think that the multiplication of age in children is a relevant hypothesis. In this case, it's a little bit contrived, but there are real reasons why you would do that in a data set. Well, the one way that you could do it, right, is you could go and you could say, okay, I'm going to make an Excel formula, and that's age, so that's A, and then that's times children, so times D, A2, oh, sorry, so equals A2 times D2, which must be wrong because it should be R2 D2, but never mind that. And then you could do that for each particular thing, right? Like you could go in and do that. But the problem is when you want to do that kind of column manipulation, it gets a little bit tricky because you're having to go in and add that in Excel. This is where the stuff from Sneak Attack on Amanda, where the addition of these extra column addings come in really handy because you can do these calculations across an entire column. So what we're going to do is we're going to say frame, add column, and we're going to find this one that says text column, text source. We're going to give our column a new name called multiple. I just made that up. Actually, no, I'll call, what was it? The combination of age child. There we go, age child. And then we're going to tell it what we want it to be. And so it's age times children. And because we're masochists, just to verify that it works, we're also going to print it out. But just the first couple rows, just to make sure that it worked. So I'm going to run this. And look at that. I've got a new column called age child. I'll put this in the Slack. Age child is 19 times the number of children, which is 0. So 19 age childs. Now, you laugh because this is a bad example, but there are areas of science where this is very common. Force is equal to mass times acceleration, right? So oftentimes we do this in science, we just don't usually do it for the number of age children, right? Because that's very silly, right? You get it. In fact, it might not even be a bad idea to just say, well, it doesn't matter. So the point is, now that we have this column and it's only doing it in memory, this doesn't go on your hard drive. You can save the file back if you want to, but that's not really the point. Now that we have that new column, we can use it in our chart. So what that means is, instead of going in and manually messing with all this junk in Excel, we can say, hey, do all these calculations for me across the whole column all at once, and then use that in my chart on the fly in RAM. Okay, so in this particular case, I can then say, instead of having region, I can have age child. And ta-da, I now have a new chart with the illustrious and very important scientific, super scientific, which is even better than scientific, somehow, relationship of age children. Okay. If I run that chart, actually, that's really funny. I get this. And this particular chart shows that the trend line goes from 30 to about 32.5 or so. And it's clumped in the lower end of age childs and then goes up, but not by a whole lot. So do you get the point? The point there was sometimes when you're doing exploration, you start by looking at the columns, but you can also look at the combination of the columns, and you can use that add column function to do that in an easy way. You don't have to go back through your spreadsheet and make all those modifications yourself. And the reason you don't want to do that is because then you don't have an automated script that can let another scientist reproduce your work from the raw data. And that's really important. That's important because otherwise it's very difficult for someone else to reproduce your work. And in science, that's kind of the name of the game, right? Everybody should be able to get the same answer from the same input. Okay. Questions? There's plenty more to talk about with these scatter plots. We're going to get to the stuff Derek was asking about in a bit. What if we have factors and all these extra stuff? But any questions so far? Okay. All right. So we're going to take then a 5-minute break. And when we come back, we are going to be adding on factors and facet separation. If you don't know what those things are yet, that's okay. So I'll be back in 5, and then we'll make this graph even more crazy.
Graphy.
Graphy, yes.